Hello, this is Carl with Airfoil Generators. Thought you'd like an update. What you're looking at right now is the M6 Airfoil Generator in pieces on my print shop floor. We're printing more parts right over there. You can see there's some more rotor segments on my desk, but this is what it looks like as we take the first printed pieces and kind of set them together and so on to make sure that they fit correctly as this thing grows, one segment at a time. The gray areas represent the airfoil. We printed that in gray, and the white is the rotor or the impeller, depending on where you live. Of course, that's each blade of the impeller, and obviously there's 5 of them. The aluminum shaft is the drive shaft. So as the rotor turns, or the impeller turns, the drive shaft turns, and that turns the generator. I just thought this might give you a very clear understanding of how this works. And it happens to be, by the way, oriented the way it will be outside in the field. The drive shaft is vertical. This is a vertical axis wind generator, and the rotor turns this way. Now, important features that the airfoil provides. Looking at the gray airfoil, this is the nose. This is the way the wind will be coming. The wind will be coming in that direction. And as it hits the nose, some goes underneath or around the side, if you will, of the airfoil generator. But more importantly, the wind that goes over this side has to go faster. So that's called an augmented airfoil generator, in that we're going to augment the natural wind speed, whatever it is, and we're going to make it move faster than it was a moment ago. And we accelerate it because that gives it more energy, and we like that. And the wind then hits our blades, causing them to turn. So by increasing the wind velocity before it hits the blades, we get more energy from the wind. That's a good thing. Then there's the drag component. As the blades on a vertical wind generator go around, they reach a point where they have to start going back to the front. And that's a problem, because without a shroud, which is what the airfoil generator is doing, without a shroud, the blades are going back uphill against the wind to get back to the starting position where they can go back around again. And that's like I said, a problem, because it's a loss of power in the drag. So what the airfoil is doing for us in this case is it provides a shroud so that the blades can return to the starting position without going upwind. So we save all that energy, and we take the energy when it's going in the right way, and we don't spend any energy when the blade happens to be going the wrong way. So we shroud it. So that's why this is referred to as a shrouded and an augmented wind power generator. Just an explanation for you. Anyhow, that's enough for now. As I print more pieces, this thing is going to continue to grow, and I'll post another update. Thank you for listening. Bye-bye.